Hello, everyone, and welcome back to Learning with Jelly. Today is day 22 of our 30-day SQL challenge, where we're going to be discussing window functions. Now, the agenda for today, I've already introduced you to the window function row number in part one, but we're going to take a look at it again. And then we are going to discuss the differences between rank and disrank, and then the lag function. So if you are new to the SQL challenge, welcome. The whole goal is to learn SQL, preferably 30 days straight, in order to enhance your SQL skills, to apply for projects, to land entry level data roles. You see two QR codes on the screen in front of you. The one on the left is the topic list, where I list the videos as well as supplemental resources. And the one on the right is for our Facebook support group, where you can ask questions about the videos, find a study buddy, help troubleshoot, and more. So let's just review from part one exactly what window functions are. So, window functions perform calculations across a set of rows using information from other rows. It returns one result per row. So, unlike other aggregate functions, like if you take the average of a group by, it'll only give you one result versus keeping every individual row that already exists in the table intact and giving you a result per row. So this is very useful for things like running totals, and we utilize running totals in part one, moving averages, cumulative sums, especially moving averages when you're trying to forecast like stock prices or price prediction. It retains the row level detail. So maybe you want to look at all of my purchases individually and not just an average of all of my purchases. And it also can help your queries run faster. So window functions are great when we want to keep all of the rows that we have in our table. So here is a list of some window functions. This is not all. So there is row number, rank, dense rank, and lag. And we're going to talk about each one of these individually. So for row number, we saw it in the first video, but we're going to review it here. You assign a unique integer to rows within a partition. And keep in mind that a partition is like a slice of the set or like a subgroup that you want to perform the function over. So in this case, we want to assign a row number to each customer's invoice. The invoice that is the highest amount should be numbered first. So you can see here that once we partition by customer ID, I can look at their individual invoice totals. I have one at 594, 198, another one at 198, and so forth. So row number is just going to do 1, 2, 3. It's going to start counting over again when it hits the next partition, which in this case would be a new customer. So when you're looking at partition by, think that the function is going to start over again once it hits a new partition based off of what column you put in the partition by. So let's actually code this out. So let's go to SQLite Studio, and we're going to code this window function and then modify this window function for every other function in this lecture. So let's go ahead and select the columns that we saw on that screen. So we still had invoice ID, we had customer ID, we had the total of the invoice. And now we want to do our function. So our window function that we want is row number. And then since this is a window function based off of part one, we always have an over that comes right after a function. So that could be row number, it could be sum, it could be average, it could be lag, but you want to put your function first and then over. So now inside of this parentheses for over, we want to do a partition. What do we want to apply the function across? And we want to partition by customer ID because we want the function to start over once it hits a new customer ID. And we want to also be able to assign a row number based off of the total. So the first number is going to be with the highest total. So I'm going to do an order by. This allows us to order by total descending. In here, and I kept it on 2 lines just so that we can see it. Yours can go on 1 line. And now we can output this as an alias. So I'm going to call this as row num. Now, since we have our select intact, the next clause is from, and all of this information comes from our invoices table that we can look at on the right hand side of our or left hand side of our screen. So invoices. Okay, so now let's run this. And this is what we get. So we see that we're actually assigning a unique number, and the count starts over as soon as we hit a new customer ID. So that is what that partition by is. So I want to do the row number function, and I wanted to apply it over this window where I want to do row numbers and start over by customer ID. In the first number, I want it to be the total column that has the highest amount. That's what that order by total descending does. Great. So let's hop right back into our PowerPoint. So the next function is going to be rank. And for simplicity purposes, we are going to pretty much utilize the same query, but just change the function within this query. So rank is going to rank the rows within a partition with gaps for duplicate values. And you may be wondering, what does gaps for duplicate values mean? So if we look at this snapshot here, we have our row number. Now, when we look at customer ID 1, we see that we have totals that are tied in this case. So they are going to be ranked the same value. But notice that the next customer one's invoice is ranked number 4 instead of ranked number 3. So it actually gaps or skips over the next number in line if it has a tie. So in this case, we have rank 1, rank 2, and then rank 4. We don't have a rank 3. And that is going to be the main difference between rank and dense rank. So when we're thinking about the use case here, we're ranking each invoice a customer has with a 1 for their highest invoice amount. So what we just did. However, invoices that have the same amount should be ranked the same number. And you can kind of look at a comparison here between what row number will give you versus what rank will give you. So let's hop right back into SQLite Studio. And now instead of having the row number, I'm actually going to keep row number there. Let's just build on this. Let's do rank. And we're going to do another over. And let's go ahead and partition by customer ID because we want our count to start over when it hits a new customer. And we want to go ahead, and it's red right now because I didn't add my comma. No worries. Order by total descending. Same thing going on here. And I'm going to put this as rank. And let's go ahead and put a nice little comma at the end of that so it can take that off. Great. So now let's compare these two. And this is what we get. All right, so this is customer ID 1. All right, so here we see that for customer ID 2 that we have a tie. And so row number is giving us out a separate number for each of the invoice amounts, but the rank is saying, hey, they haven't actually purchased an invoice that is greater than 1.98. It's actually the same amount. Okay, so that's what rank does for us. And I highly recommend that you practice this. And let's keep going. And now dense rank. So now we're adding dense rank. So it's similar to rank, except for it won't have the gaps in the number. So in this case, for rank, we have 1, 2, 2, 4. In this case, for dense rank, we have 1, 2, 2, 3. So it's not going to skip over the third place. It's going to go to the next sequential number. So the main difference here is that invoices with the same amount should be ranked the same number, and the invoice after should be the next sequential number, as we see here. So let's go ahead and actually apply that too, so we can look at our comparison. Let's add our comma. And now we have dense rank. Once again, we want to apply this function over a window. The window is going to start over by customer ID. So we're going to partition by that. And then we're going to do the same thing. We're going to go ahead and order by total descending. And then we're going to put this as dense underscore rank. And then we're going to run this. And here we see our output, and we can go back to that second customer here. So we know customer 2 is here. Our row number just gave a unique integer for every invoice, no matter if the value was tied or not. Rank gave the same number for an invoice that had the same amount and skipped the next number in order. Dense rank gave the same number to invoices that had the same amount and went to the next number in order. So instead of 557, this one is 556. Awesome. So let's look at our last function, and that is going to be lag. And lags are very good when you're trying to do like financial metrics, such as, like I said, prices or some budget, operational costs. When you're trying to do forecast or time series analysis, you may utilize this function. And pretty much what the lag function is going to do is going to move everything down, in this case by 1. You can move it by 2, you can move it by 3, and so forth. So in this case, for customer ID 1, the total was 5.94 and the previous total was 0. So we didn't, because this was their first invoice. Then, as you can see, for their next invoice, it was 198 and the previous was 594. So we can actually use these two columns to calculate a change or a rate of change or some type of difference, which may be beneficial when we're doing our analysis. So as you can see, each number kind of lags by 1. It's on its diagonal. So let's see how we can actually code this in SQLite. Once again, we're going to use that same query. I'm just going to put a comma at the end. And we're going to do a nice little lag. In the lag, we need to tell it exactly what column we want to lag. So I want to lag the total column. And I want to lag it by 1. And the first value should be a 0 if it had nothing before it. This is still a window function, so we need to partition. So I want to partition by customer ID. And in this case, I'm going to go ahead and order this by invoice ID, because I already have my total in that nice little lag function there. So order by invoice ID. If we can spell today, so hard. And I'm going to put this as prev total to stand for previous total. So now let's see what we get. In here, we have where we have our 13.86 coming up here. For some reason, this must be had a also previous. So this one was actually the first one in the data set. Okay, interesting. So the previous one for this one was 13.86. The previous one for this one, it was 3.96. I can tell when I have a previous total equals 0 that this must have been the first invoice in the entry, and so forth and so forth. Outside of lag, there's also lead. So you also can look up lead. But this is just to give you some exposure to some window functions that are available to you. All right. So that was our demonstration to understand window functions conceptually. Just think of it as a function that can retain row level detail. And sometimes you really want to know the row level detail so you can calculate things like running totals or moving averages, things of that nature. So please, please, please research window functions more. They are super complex when people are learning it for the first time. I'm going to link the topic list and Facebook group in the description below, as well as my Etsy and Buy Me a Coffee. Please, please, please like, comment, and subscribe. It does help the channel out. And I look forward to day 23. Thank you so much. Bye bye.